Let's get started. Hey, everyone. Welcome to the CI Campus webinar on verifiable credentials and digital wallets. The webinar will consist of a presentation followed by a Q&A session, right, Erik?
Right.
Yep. So I have the pleasure to introduce today's speaker, Erik Scott. Erik is a computer scientist at UNC Chapel Hill's Renaissance Computing Institute. He's a major contributor to the CI Campus project and provides expertise in a broad range of topics in data management to the NSA major facilities to design and improve their CI. These include identity management, data processing, data archiving, and curation, just to name a few. In his tenure at RENCI, he has worked with scientists in fields as diverse as genetics, economics, geosciences, and medicine, a breadth that has proven useful when working with similarly broad range of major facilities. So Erik, when you're ready, please take it away. Thank you.
Certainly. Well, welcome to a introduction to verifiable credentials. We'll talk about what that is and why it's receiving some hype. To give you a little metadata about this, the CI Campus project, helping NSF major facilities with their cyber infrastructure, we still have a identity management working group in which some representatives from the facilities and some Campus people, we got together once a month and talked about issues of importance in identity management, which is a lot more than just usernames and passwords, although that's certainly the first piece that people touch. That's the first point of contact for most people, and that's where you really get to start the discussion. That working group met for about 2 years. We talked about a lot of topics: LDAP, shibboleth, in common, OIDC. I mean, we had lots and lots of topics that we talked about. And as we kind of narrowed down what the facilities kind of wanted to do, in a lot of cases, we started a little bit of research to find out what the state of certain things are. And we haven't met as a working group scheduled. It's an ad hoc thing now. And so what I want to talk about today with verifiable credentials and decentralized identifiers is an aspect of that. So this is one of the branches to go out and see what's going on, and we're going to report it back to you in the major facilities. So let me here. All right. Move this so I can see all of my screen. Verifiable credentials has generated a lot of interest in a fairly short period of time. Most of what's written on this, the work began before then, but most of the publication really starts around 2017, 2018. It's a fairly new topic, and it is focused on user privacy for once, how to not necessarily have to share every piece of information about yourself with a big online service. How do you control just how much Facebook is able to learn about you? So we'll talk about 3 things. The first one is, of course, verifiable credentials and why that matters. The second big topic is decentralized identifiers, which is the basis that verifiable credentials are built on. And then just in passing, really, we'll talk a little bit about digital wallets and how they make verifiable credentials feasible in a lot of cases. So right now, with the identifier scheme that the web has kind of grown into, It's very unwieldy. Okay, so who has a little notebook with your usernames and passwords for all the sites that you use? You got your Netflix password and it's been crossed out 10 times when you change it, right? And then you start thinking to yourself, well, so all these websites, they give me an option, oh, just log in with your Google ID. And well, that's very convenient. Because now that gives you one username and password to remember. That's a lot easier. So that means Google now knows every time I go to another website. If I log into WordPress, we'll talk about that in a minute, with my Google ID, Google knows I'm using WordPress and they know when I'm using WordPress. And they might be able to start to extrapolate some other information from that. So what we want collectively is a way to control how much information we give out. And the reciprocal of that is how much information we leak. Think of it in either term. Control how much information we give out to somebody that wants to verify some claim about us. We might claim, this is my username. We might claim I have an undergraduate degree from NC State. We might not claim that, but we want to be able to make claims and prove that those claims are correct to a consumer of that, a verifier of that. So speaking of WordPress, how do we log in right now? A couple of options. Okay, username and password, a little notebook we carry around with all our usernames and passwords, or we use a password manager service. LastPass it's an online version of that little notebook. A lot of digital wallet schemes, some built into the cell phone, is ultimately just an encrypted digital database of that little notebook of usernames and passwords. The alternative is to use some other identity provider. I'm going to pick on Google a lot in this presentation because they're so ubiquitous. But there are other providers of identity, and they all have a little bit different policies. There's your Microsoft ID, a GitHub ID, which can be actually used among many independent websites. They haven't been merged yet. A lot of different providers. So I'm not really picking on Google. I'm just using them as an example. Right now, the situation we have when we try to do a federated login using Google, tremendously simplified network exchange here, because there's a lot of things that can happen in the background. But you go to WordPress, you hit their login page, and you say, well, yeah, I'm going to use my Google ID for this. So WordPress sends you over to a Google page, and you log in on that page. And there's enough information that was passed into that request that Google knows how to send you back to WordPress with an encrypted token that says, oh, hey, yeah, they are actually who they say they are. Try to fix, yeah. So why not just use that? It works. Well, there are privacy problems. Okay, so if I do that, now Google knows I'm using WordPress. Okay, so I might suddenly start getting a lot of ads for Blogger instead. They know approximately what time of day I'm using it, which is going to give them an pretty good idea of whether it's a personal project or if I'm using it as part of my job. And I don't have very much control most of the time on how much information is shared between Google and WordPress in this case. The protocol allows limitations, but the user interfaces, that's less common. They usually don't give you a series of check marks on what you want to exchange. So verifiable credentials step in here and say, I can solve all your problems. Well, many. So the general gist of it is a verifiable credential is a digital thing that a user has that will prove a claim. Like as a user, I can claim I'm Erik Scott, and I have this little file, a verifiable credential that contains the assertion of the claim that I'm Erik Scott, and here's an identifier. The state of North Carolina Department of Motor Vehicles, they will testify that that's my name. Stored in a file, a little piece of JSON. Okay, so I get that identifier at some point. I turn 16. I go and get my driver's license, and I get that identifier. And then I keep that identifier, that verifiable credential, I keep it forever. It doesn't have to expire. You can put an expiration date in it to force renewals. That's not a bad idea, but basically it sticks around forever. I hope a century from now, I don't know, 50 years from now, I hope I still need it. So I keep that verifiable credential, this little JSON file, keep it potentially forever. And then anytime I want to log on to some service and I want to log on to WordPress and say, hey, I'm Erik Scott, let me in. I can give them a copy of that JSON. WordPress at that point acts as a verifier, and it checks to see, oh, is this credential real? Has it been forged? Has it been altered in some way? Let's make sure it didn't expire. It can check a lot of those features. In fact, it can check a lot more stuff. So we have these four parties. The subject in this case is, if you're identifying a person, it's the person you're identifying. You can identify a lot more than just a person. I could have a credential issued for this mouse with its serial number. And my computer could check every time to make sure that that's an approved mouse that I plugged in. Okay. But the subject is what is being identified. The credential that gets generated is kept by a holder of that credential. Most of the time, the holder and the subject are going to be the same person, the same entity. And then the issuer we talked about, the entity that is testifying, yes, this certificate contains correct information. And then finally, the verifier, right, like WordPress. So the protocol, the simple use cases are simple. So let's start with a simple one. And when it gets complicated in a hurry. And I'll just gloss over a complicated one. Don't worry, we will not be drawing state diagrams on the board. Good thing. So our subject, our user, our person goes off and asks an issuer of credentials, asks them, say, hey, give me a credential in which you testify that this claim that I'm making is true. I could make a request into NC State and say, I need a credential, verifiable credential generated that testifies that I'm Erik Scott and I did my undergraduate degree there. And the registrar's office will look and we'll go through some procedure not defined, out of channel. Chances are they'll make me drive to Raleigh and show them my driver's license because that's just how they work. And I don't blame them. At some point, then the registrar says, yep, you're Erik Scott. Let's check. Yep, you did your undergrad here. Okay, here's a JSON file with some signatures in it that we agree. We testify you're Erik Scott and you went to school here, by goodness. So that's generated and it's given to me And now I need to store that. It's my responsibility to keep up with it. NC State probably would keep up with it. And we'll talk about reasons why in a few minutes, but I need to keep that credential, copy of that credential forever. So I probably need to back it up a whole lot. I need to also store it in ways that are reasonably secure, because there are things in the plain text, quite possibly, that I don't want the whole world to know. Like my undergraduate GPA. Okay, my freshman year was bad. Let's just accept that. So we keep this credential forever. We've got a generated verifiable credential. That credential, like I mentioned before, can have an expiration date. One thing that issuer, in this case NC State, one thing that issuer did when they generated that credential, they also produced a cryptographic hash of that credential. And they stored that hash out in plain view for the whole world to see in a blockchain, in a distributed ledger with non-repudiation. In practice, that's going to be a blockchain. And it's nice because it lets them assert that they generated this certificate. It gives them a way of proving that they generated the certificate. And importantly, it's a way of detecting if anybody's tried to tamper with the signature of the credential. So yeah, blockchain, can't get away from it these days. It solves some problems and it creates some problems. We'll talk about that in a little bit. And now, continuing the WordPress example, let's say I go back to WordPress. They say, all right, we need you to log in. Do you have a username here? No. You want to use your Google account? Nah. Can you send us a verifiable credential? Sure. So I find that JSON file that contains my verifiable credential, that digitally signed piece of JSON, and I send it to them. Maybe it says it's got my name and who is actually making who verified the assertion that that's my name. Then WordPress, they generate a hash of that credential, and they go back to the blockchain and check that they match. So the one that NC State issued, check its hash against what you just produced. And if they're the same, then you've got a certificate that you've got a credential that hasn't been altered. Okay, so at that point, you know you're looking at a verifiable credential that was actually issued by an issuer that you trust. You can trust universities, right? Real simple. Okay, implement this in 500 lines of Python and we're done. At least with the easy stuff. Okay, so that is the simplest use case. Fortunately, it is the one that everybody envisions is going to be used the most often. That's an important thing to do. Keeping track of usernames, identities, important, and it handles it in a way that's simple enough that if you drew it on a whiteboard, you could explain it to a kid. It's pretty simple. How do we handle all the corner cases? What makes this job hard? So for one thing, we want to ensure that we're sending a minimum amount of information. If NC State has issued a verifiable credential that my name is Erik Scott and I was an undergrad there, currently they issue one kind of credential. It is literally a piece of paper with a stamp on it that lists my name and that I went there and when I went there and the grade that I made in every class. And that may be more information than I want to give WordPress when I log in. So we need to have some control over exactly how much stuff is being contained in that credential. if we send too much information, the danger is that we're going to start leaking things that we don't necessarily want to be public. I don't necessarily want the entire internet to know what my home address is. If there's enough information in there, you can start to actually, you can pretty easily put together a pretty comprehensive extension of what you know about them. The case of the governor of Massachusetts having some of his healthcare information revealed, so the poster child incident for that. Nice, complicated special cases. So what happens when a university, for instance, needs to revoke a credential that they've issued? Okay, so maybe you were one of those people working in the German government 30 years ago, and somebody said, "Oh my goodness, you plagiarized part of your dissertation," and so the university they went to revoked their PhD. Well, how do we do this in the world of verifiable credentials? The solution in this case is that the issuer creates a new VC that identifies not the subject that's being having that credential revoked, but that identifies the original VC itself. And then it has a field in it that says this is a revocation. So that gives a mechanism for marking a credential as invalid. The verifier, WordPress, they'll be responsible for checking to see if there is a revocation credential paired with my "this is who I am" credential. Another special case that could pop up, disputes, and disputes includes changes. Yeah, in fact, I'm having this problem right now with a government agency. You spelled my name wrong, right? So if I'm disputing that in the time before a new credential is issued by that issuer, I need a way of saying to the world, "Hey, this certificate, it is about me, but it contains information that's wrong," and that will let a potential verifier understand that, yeah, if you're looking at more than one verifiable credential, then it's possible that there might be fields that don't match. They could contain errors. One error that we're particularly worried about is identity theft. If somebody's able to generate protocol, whatever it is, to convince some university to issue a credential that actually belongs to somebody else. And that doesn't have to be an online attack. You know, that could be as simple as just making a fake driver's license and walking in. It happens. So the verifier, they're responsible for looking at those. The one area where this really starts to get off into the weeds, and I am going to gloss over this, mostly give you an idea that it can be done, and give you a starting point for where to look at it if you need to. One of these is the idea of a derived credential. And in this case, what happens is the subject has a credential or two or some number of credentials, and they want to generate a new credential based on those. And they don't want to have to go back to the original issuer. Maybe they can't go back to the original issuer. So we need a process where I could edit a credential. Yeah, that is a potentially dangerous thing to do. So given this hypothetical NC State example I'm using, all that information in there, including my transcript. I want some way to be able to go in there in Emacs and hold down Control K for a while and delete that whole transcript and just say, yep, I graduated from there. That's all you need to know. But at that point, I've generated my own custom credential by hand, and I'm the issuer. Can you trust a credential from me if I'm the subject and the issuer? No, actually, no. So we need a mechanism so that the amount of information that is exchanged can be reduced by the individual, so they can say, I don't need to leak all this information just to go log in and edit my blog. I'm using an example here on the slide yeah, instead of a transcript, my example here is, oh yeah, they don't need to know what you majored in. You know, that's some very similar example. So yeah, we could just edit that. We could just edit that credential, send it on, but then we've lost all of our security, right? There's at this point no way of knowing that it's real at all. Because that person is just self-certifying that they're that person, you've got no evidence. Fortunately, there's a way around that, and it is a family of incredibly elegant math called the zero knowledge proof. And it is a tool that allows you to tell if a person knows a particular secret, and tell that more or less positively or within statistical limits, your choice, to tell that without actually having to reveal the underlying information. It's pretty cool. So you have two parties in a zero knowledge proof. The prover is the entity that wants to prove that they know a secret. And you have a verifier who does not know that secret and can never know that secret. It's important that they not know, but so that verifier can somehow tell if the prover actually really does have that secret information, right? So things like WordPress could ask, can you prove to me that you know your password without revealing your password to me? And there are ways to do it. This reference here, really recommend this one if you're curious on how they work, because it is literally the simplest way this could be implemented. And you literally could explain it to a talented third grader. At least that one example. Okay, it gets pretty crazy as you dig deeper in. So with zero knowledge proofs, there's a couple of ways to use them. You can use them what's called interactively. There doesn't have to be a human in the loop, but the prover and then the verifier, if they can communicate back and forth repeatedly, then you can create you can compute the probability that the prover actually does have that information. And you don't have to run a whole lot of cycles to get really good statistical support for the idea that, yeah, they really did know that secret. You can make this thing effectively converge very, very quickly. Another case, though, if you're not going to be able to have a lot of interactive communication, you can use hashing functions. Now, everything at that point relies on trusting that your hashing function really is irreversible, or that is sufficiently difficult to brute force. And yeah, if you really trust SHA 256, so far everybody does, then yeah, we're in pretty good shape. If we construct what information needs to be known and can you prove you know it using a zero knowledge proof, it's complicated, but you can show that the issuer was only able to generate that certificate, only able to generate that credential because they had a credential from the issuer they claim it to be from, and they removed information from it. Okay, so you can write proofs to do that. So let's take a moment and see what's actually being exchanged here. And this is split over 3 screens, so we can actually read it. The first little lump of JSON, we got an array of strings in there in which we're specifying context, essentially a schema. We're saying, okay, we're exchanging a verifiable credential based on the 2018 version in the World Wide Web Consortium. Then we have ID, the identity of the subject. And that's kind of an interesting way of specifying that. We're going to talk about that in a minute. And what type this is. So it's a type of verifiable credential of a standard type called an alumni credential. Okay, this is documented in a W3C standard, what that JSON needs to look like if you're testifying that this person really is an alumnus. The issuer, we have an identifier for that and when this thing was issued. Then as we go into it, this is the next part of the payload, the verifiable credential that is being exchanged. The next part, we have the identifier of the subject, that alumnus, me. We have the identifier of the institution that I'm an alum of. So that's this second ID field down here. Oops, can't click on it. And then we've got some convenience tags that are put in there. Human readable name of the university. We can do it multiple ways. We can make it either or things. Yeah, institutions there are institutions that have more than one name. Then finally, we get to where we have the proof of knowledge that we're looking at something that's valid. Now, in this case, because this is the simple case, nothing's been removed, this is not a derived credential, we can get away with a really simple proof. Digital document signatures, plenty good enough. Here's an RSA signature. Down here at the bottom, a whole bunch of characters generated, and it is stored in that would be the representation of a field, a standard container for that. So let me go back here. These IDs, all right, nowhere in here have we had the name of a person. So if this is my identifier, you can't tell I'm Erik Scott from this, not just by looking at it. So we have this ID, and then this string here that begins with DID example, a whole bunch of gobbledygook. This is where the work is getting done. Okay, this distributed ID example is the underlying bones that this thing is built on. So what is a decentralized identifier, right? If it's so important, we better talk about what it is. It is a way to specify a globally unique identity. Think if you're a programmer, and especially if you had to deal with Windows, if you've ever had to use a GUID, globally unique identifier, 128-bit number generated in a way that every one of those will be unique in the world. This is a little bit like that. This allows unlimited numbers of unique identifiers, but it's really just a way of generating a long bit stream that identifies something that's guaranteed to be globally unique. We have defined in here a way of taking that string that we just saw and turning it into a JSON record that describes that entity in more detail. Think of this as like a DNS lookup, right? When we look up www.renci.org, we get 4 numbers that come back with dots between them, right? The IP address, DNS, domain name system. It's just a way of mapping a readable identifier onto something that we lose. When we look at it, we lose the ability to we lose the human readableness of it. So that DID, that distributed identifier, is a URI, a uniform resource identifier, not a URL. It's a URI, and we saw that it was in the form of DID, colon, and some other stuff. Well, the first one, DID, that is. It just says, hey, it's a decentralized identifier. The second part between the 2 colons is the method to use. And it'll, there's a mechanism by which you can define DID methods if you want to create your own methods. There are already standardized some existing structure for doing this. If you feel like hashing is a good enough solution, there are a few options for that. And then finally, the specific identifier for that method. Okay, so this long 1, 2, 3, 4, 5. That is the core of that identifier. That's the part that is the unique identifier. If we take that URI, we can convert it to a DID document, another JSON file that contains more information. The method, that second field, the DID method to use, part of that specifies how to do a DID document lookup based on that URN. So we could look up that previous document and we could get some information back about it. Okay, so for this identifier, that ID that we used, we want to authenticate it via it's a public key signing algorithm. So it's signed, it's got a public key signature. The party that's responsible for that ID, okay, that ID might refer to a human, in which case the party responsible for that is that person. I'm responsible for my identity. But if my mouse has an identity, then the controller for that is me. Okay, so the controller has to come back to a person with authority to issue that distributed identifier. And then we have a little bit more information that depends on what kind of authentication you've selected. Do you need a public key in there? Do you need a hash value in there? As you go through the standards documents for this, you start to get the idea that it is very, very much a work in progress. There's enough that works right now to have interoperable usernames, federated login in the simple case, and some of the a little bit more complicated cases. It is still very much a work in progress. As you read the standard documents for this, you start to see that there are a very large number of aspects of it that have an extension mechanism, so that you can create your own way of doing something and register it. Because why have one standard when you can have 10,000, right? It'll handle, it's made to be expandable, extensible. So if you've got really special cases and there's no alternative, you can create your own, method, put it in there. Most of these implementations, to actually be able to guarantee global uniqueness and to be able to guarantee to a verifier that it hasn't been tampered with, these implementations generally also use some kind of distributed ledger, blockchain. When you start seeing everything in distributed ID, verifiable credentials, self-sovereign identity, having a publicly readable, immutable record of what happened becomes the foundation of how these things work. And this is no exception. Playing with it right now, you got a few options. There are a good collection of libraries to do a lot of the work for you in actually implementing this. There are a few commercial implementations. Microsoft's Azure AD, their Active Directory, outsourced Active Directory, plus other features, it runs on their cloud. There is support in there for at least the fairly simple use cases. It's not perfect. I wish it was, but it's still, there's still things you got to watch out for. You have to be careful in what information you exchange and being careful not to exchange too much information. So you may need to have a mechanism that's creating these derived credentials, and you may be using it fairly frequently as a user, right? So if you send different things, either to different websites that collude, or if you send multiple different things to the same website, they can start to piece together what the entire credential would look like. If somebody's able to snoop on your network and hear the packets going across, can they, is there an opportunity to take advantage of stealing that verifiable credential in transit? Two ways around this. I think every implementation actually uses HTTPS as their uses TLS encryption as their communications method. So you get some privacy there. The other thing you can do is that during the exchange, you can build in a serial number from an issuer, and verifiers know that if they ever hear that serial number twice, the second time was a replay attack. So that is so that's how it gets some protection against replay attacks. And finally, like I mentioned, this implementation of this is about half of the standard stocks, and what's in there is it's a good start, but some of it is at the state where I think it might be formal enough that we can actually reason about it, but it is layers upon layers. All right, so that was a quick and glossy introduction. We are going to be seeing increasing use of verifiable credentials. We are going to be seeing increased concern for privacy. Maybe not actually from the users, but it may be coming from some of these large web businesses as they begin to attack each other. Okay, Apple made some privacy changes in Safari, and it's caused Facebook to have a couple of earnings misses because they're not able to target ads as well. So this kind of thing, we're going to start seeing it more and more. We're going to see it coming out of Europe with Europe's digital autonomy efforts. They don't want to have to rely on Google IDs because Google's not a EU company. This is going to become more common. We're seeing it built into vendor software now.